So the supply's been on for quite some time now. I've got the incoming line voltage up to the full line voltage. The outputs look okay. I'm going to go ahead and I think adjust the supply rails, and then we're going to load the +5 and the -5 with constant current loads and just let the system sit and bake for a bit. So if I remember right, this is +5 and it's spot on, 5.0024 volts. Let me look and see if that meter's actually readable or it's not. This is always a pain, the glare. That's better. I think you can read it there. Nope. Nope. Can I get it where it can be read? Looks like that'll work. Let me come back around again and we'll look at the 5-volt supply. And it's right at 5.002. It's spot on. I believe this is the -12. It's a little bit high. So I'm going to go ahead and tweak it down. And -12, I believe, is this pot right here. So we'll see if I have any luck. Tweaking. Way too low. 12.1. That's closer. So that's -12.06. And if we move this over to the +12, I think this was about 12.2, 12.1. Let's go ahead and try to bring it down a little bit. Oh, went the wrong way. Okay. No, it's still going the wrong way. Pot hasn't been tweaked for a while. There we go, 12.2. Yep, I'd rather be a little bit over than under. Not that it makes any real difference. So, okay, that works. So let's go ahead and shut this off. Unplug. And unplug over here where you can't see because I want to get the variac out of the way. On again. Let's try to adjust for an amp. An amp is reasonable here. There's a bit over an amp. Let's see what it believes the voltage is back here. So it believes it, so okay, so it's 4.98 back here and it's 4.91. And that's just line loss. That's just loss at an amp of current in the circuit here. But that's drawing an amp. The fan is moving slowly. I'm just going to let this cook in this case like this. I don't expect the board to be drawn more than an amp. Can I clip on there or not? Of course not. Clip on there and not cause a short. Let's take that back down. 4.98 volts. Bring the current up. 1.01 amps. And I'm just going to let this sit. So we've ran the 5-volt load testing overnight, which is the constant current load here on this meter. We looked at this earlier in the video. We were drawing 1.53 amps overnight. I powered things off and back on to hook up some additional stuff. We're still seeing the about 0.17 volt drop through the wiring here, etc. Just due to the 1.5 amps being drawn through this gauge wire and mechanical connections and stuff. But I was curious and wanted to play more with the 12-volt side and add additional load to it. Using the electronic load, we saw it go into a weird clamp mode almost immediately, dropping the supply output to 0.37 volts, which just didn't make a lot of sense to me. And I've seen this before with these particular constant current loads, this design on other 12-volt rails, so it was just really kind of odd to me. So instead I have grabbed off of my rack, my test instruments, this high power resistance substitution box. This was rebuilt by who knows who when, and it came to me to be rebuilt, and I rebuilt it, and it's full of high power resistors, and it's got some switches here, or some, multi-position switches that I can select what the resistance is, and as you can see, it can go from 1/10 of an ohm to 99.9 ohms. Right now we are set to 90 ohms. The supply is outputting 12 volts, and it's drawing 129 milliamps. So, that seems reasonable. Seems pretty close to me. I haven't actually done the math to know if that makes sense or not. Oh, my TI-30 is dead. Needs a battery. We'll fire up the Unitrex here, and if we take 12 volts divided by, where's divide? 90 ohms, we get 130, we get 0.13 or 130 milliamps. So this is very close to what I would expect. It's off by a milliamp, so this makes perfect sense. So as I decrease the resistance here, there's 80 ohms. We'll see the current go up. 70 ohms, 60 ohms, 50, 40, 30. We see there was a little bit of change in the voltage, just a little bit of noise added. At 20, we see the voltage start to drop, and it's dropped pretty substantially there. So at 474 milliamps, the 12 volt rail is starting to collapse. And we can see here we've crowbarred. So we're about 475 milliamps, and the voltage has dropped off to 5.4 volts. So whatever the design is, the supply has gone into... I don't think this is a problem with the supply. I think it's actually in some kind of a crowbar, some kind of a current limited mode here. So we can bring this back up to 30 ohms. Let's collect this guy all the way up. Actually, I've got a 1/10 switched in there. And let's go to 29 ohms. And we can see we're at 395 milliamps. And we can start to decrease the resistance here. We can see the voltage being affected between these jumps. As I take the resistance up, the voltage increases. As I take the resistance down, it starts to decrease. It's way down there in, what's that, microvolts down there? Anyhow, let's keep adjusting down. So there is 26 ohms, 25 ohms, 24 ohms, 23 ohms. And we can see the voltage has started to drop off. 22 ohms, it's really dropping. 21 ohms. At 20 ohms. So, as far as I'm concerned, the supply is working. I think this is probably by design on that 12 volt rail. I guess a way to know that would be to look at the minus 12 volt rail. See how it acts. Let me bring the resistance way up. And I'm going to switch the supply off in case it goes stupid here. And I'm going to move this lead to the minus 12 volt output. I don't want to take a chance on that lead shorting to something. And let's turn the supply back on. And let's see, I need to do one more thing. I need to connect this lead to green over here, which is the minus 12 volt output. So we're actually seeing the rail we're testing on. I don't want anything there to short. We should now be seeing minus 12 volts, minus 11.93 at 128 milliamps. And as we bring the negative, and notice we're seeing negative current now with negative voltage because of the way I'm wired in here. There's 190. I'm expecting this one to react about the same, honestly. Yeah, we're seeing the voltage roll off. So the design of the plus and minus, looking at the board here, it makes sense that the two of them would roll off about the same place. And I'm not going to push the minus 12 any harder than that, even though I think it's the same basic design, using an LM723 voltage regulator. But what I can do here now is come back over to the plus 12, which is right here. Connect back onto the plus 12 here with the voltmeter. And I'm now looking at the scope. I would expect at some point to see the ripple on this capacitor here, which right now is about 0.5 volts, about half a volt. I would expect maybe to start to see it increase, and I'm not. In the end, monitoring the DC output, kind of a burn-in test overnight. I think this power supply is safe to put into operation. I think it probably could use replacement capacitors at this point. I am not going to do that work at this point. I may at some time. I'm just not going to approach it now. I just don't think it needs to be. So I'm going to throw about a 1/4 amp draw here. Okay. 2.33, 233 milliamps draw on the 12 volt. I'm just going to leave it like this for a bit, and we'll go from there. So I took a look at the schematic, and I grabbed the power supply section out and pasted it in here, and then I cleaned up the labels on things just so it would make more sense. And we've got the 3 incoming voltage rails here, +5, -12, and +12, which is these. We've got a ground connection coming in. We've got 3 capacitors that are right here, that are directly across the +5, the +12, and the -12, although I think, well, it's +5, -12, +12. That's why the polarity of this one is different. We've got the 4 diodes here that are used to create the -9 volt. We've got a 5.1 volt Zener here. There's a 4733, a 1N4733 in the position. They called for a 1N751A. They're both 5.1 volt Zeners. We were measuring, I think, about -2 volts here, so there's an issue there. There's a couple of capacitors here, and of course one up here. I think I'm going to lift them. I think I'm just going to remove all of these, and we'll test them removed from the board and go from there. I have drawn out the orientation of the 6 of them. So the band is here, and there's a plus symbol there. The band are over here. There's plus symbols on the board over here. Band, 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 and plus, plus, plus. There's a couple things I'm guessing here. Either the Zener is bad, or possibly the diode. The Zener is potentially bad, or maybe this C36's capacitor's got an issue and is leaking enough that it's pulling the voltage down. Or maybe the 820 ohm resistor, although it doesn't look cooked, it looks absolutely fine. 8.2 brown, 820 ohm. So I'm not really sure why we're getting a funny voltage there, but let's go ahead. First thing is remove those capacitors. Okay, so here's where we're at. I did some digging, and because these capacitors, the originals, were just so inconsistent, I decided to replace them. I did some digging in my stock. I found these axial lead, or radial lead. Anyhow, this body style, they're 47 microfarads, 63 volts versus 4.7. They're larger than is needed, but I think they'll be okay on the board. We'll find out here. Maybe they're a bit too big, I don't know. Doing some measuring, it looks like the original capacitors were on 28 millimeter centers, so that's what I'm bending these to. I'm trying to get the markings straight up. This one goes in with plus this direction, and this one goes in with plus this direction. Are they going to sit in place? A little bit tight, but that's not bad. I'm not unhappy with how that turned out. The leads could be a little more consistent. It's not like it's critical. Positive, positive, positive. Let's flip it over and we're going to solder those. Like I say, I'm not unhappy with that. These all tested absolutely fine on the capacitor meter. They were all within a few percent of each other for ESR and for capacitance. Like I said, they are new old stock, but they are old stock. which does mean that, over time they could have leaked and lost charge. Where's the pair of these? This looks a little truer to the original design, which pleases me. Positive on these, both go in the same direction. Like I said, that doesn't look out of place. It doesn't look horrible. Yes, that's a little bit of what I'm concerned about, is I'd like it to look somewhat original. Where is the, I want to straighten that lead up a little bit right there, so it looks a little bit like the others. Bend those out of the way, and there's one that goes back here. Plus to plus, plus to plus, plus to plus. Flip that over and solder it. So I do have some 5.1 volt Zeners. I've got one here. It's a completely different body style, but the current draw on this is so minimal. I think this only goes to the 8080 processor, if I remember right. The current draw is so minimal, I don't think it's going to be an issue with the lower wattage. Diode there, although it may be the same wattage. It's a glass package. I don't honestly know beyond, it's just, got a bunch of different ratings of Zeners. And that's a 5.1 volt one, supposedly. Power supply on, the LEDs are on. We should still see our plus 5 volt rail. We do. Our minus 12. Our plus 12. Hopefully we have minus 5 here. We do. We've got minus 5.09 here. So right at minus 5.1. So that confirms this Zener had failed. Which is fine. We've got the right voltage rail here again. If you watched this far, I appreciate it. I think I say at the end of every video now, if you think it's worth it, go ahead and give me a like. If you haven't subscribed, and again, think the channel's worth it, subscribe. And I will see you in a future video.